Here is an explanation for the answer to final exam question number 83 in Physics Demystified, 2nd edition. If you have the printed book, you'll find it on page 533. We're talking about Einstein's equivalence principle. The equivalence principle of the general theory of relativity. What does this principle actually tell us? Well, it tells us that gravitation and acceleration produce the same effects. In fact, they're so much the same that unless you have some special way of telling the difference, you can't. For example, imagine a space capsule, a spaceship sitting on the surface of the Earth. Gravitational pull causes you inside that ship to feel a certain force. That force, of course, depends on how heavy you are, but it is your weight. You experience a certain acceleration vector which produces a downward force. This acceleration vector can be considered to go up. The magnitude of that is about 9.8 meters per second squared. That is the acceleration of gravity. If you weigh, so then you know force equals mass times acceleration. So if you weigh 50 kilograms, you'd weigh 50 times 9.8 kilogram meters per second squared. That would be a force of 50 times 9.8, or about 490 newtons. You can do the math. But the idea is that imagine that this spaceship is completely enclosed. There's no windows in it. There's no apparatus in it. Just you. Of course, the engine and the fuel, but otherwise just you. You feel this force. Assuming you weigh, say, 50 kilograms, 50 times 9.8 meters per second is 490 newtons of force. Force vector goes down. Acceleration vector goes up. But there really isn't any acceleration here. You're just sitting still on the Earth's surface. Well, now imagine your, what do they call that? Nemesis? Or something like that. Your evil twin in outer space. In a spaceship just like yours, weighs exactly the same as you. The engine in that spaceship blasting away, causing an acceleration vector in this direction, straight forward or up. Now there's no gravitational pull here, no gravitational field at all. But you're accelerating at this rate, so you experience a certain force, and that force, just as before, 50 kilograms, that's the weight of your evil twin, just like you. 50 kilograms times, 50 kilograms times 9.8 meters per second squared. And that is, again, 490 newtons. That person, that evil twin of yours, will feel that same exact force. Now, his or her spaceship doesn't have any windows or apparatus either. Now, the question here is, how can you tell on the surface of the earth that your situation is any different from your evil twin's situation in outer space accelerating like this? And the answer is, you can't. You can't. All of the effects on your body, all of the effects on anything that would be inside that ship, light beams, things that you might drop onto the floor, things that you might hold in your hand and feel weight, everything, every effect will be exactly the same inside your evil twin's ship as it would be inside yours. So gravitational effects and acceleration effects, provided that they result in the same force, absolutely identical. That is Einstein's general relativity equivalence principle, and in fact it formed the foundation for his general theory of relativity. And that's choice C.